Hello, everybody. Good afternoon slash night. I think we're gonna get started. If you haven't already, please go to the course textbook under chapter 1, lecture demo. Refresh with Command Shift R because we just pushed new updates and that'll force it to download the updates. And then download the zip. And until then, Elvis has some announcements for the general course.
Yeah, if you guys aren't enrolled in CMS or Google Calendar or Ed, make sure to come up to us after lecture. Besides that, we also have our first project due the week after break. So next coming Thursday. So March 2nd, not 3rd. But yeah, any questions about that? Today's lecture is going to be basically covering everything you need to know to complete this project. So please be sure to pay attention. Yeah.
Cool. So once you download the lecture demo, you should get a zip. And then once you open it up, you should see a file like this called d1starter.playground. If you open that up, you'll get taken to this. Sorry. Yeah. You'll get taken to a place that looks like this. This is a playground. If anyone is having trouble getting up to this point, we have TAs that can go around and help you get all that sorted out. Just raise your hand and look at the TAs. If you have questions, raise your hand, look at me, and I'll try to answer them as we go. So this is what's called the Swift playground. Can people see it in the back, by the way? Is it? Okay, cool. This is what's called the Swift playground. This isn't where we actually build apps in, but this is mainly just a place to write code and test it out. So you'll see on the very left side, there's kind of this blue bar that has a play button, which if I go somewhere and I press play, it'll run all the lines of code above that play button. So for example, on line 6 or 7, I can type in print hello world. And then if I run up to line 7 or 8, it'll print out hello world. And you can see it gets printed out in the console. Another bit of I guess how this playground works, the console is down here. So anytime we say print, it'll go down here and you can see it there. But because this is mainly used for testing code, you can see the values of everything on the right side there as it's executing. So without further ado, I guess I'll start talking about actual Swift. In terms of all app development and pretty much all of object-oriented programming, we think of it as data-driven. So if you're thinking about an app, a lot of it is like, what is the data? And then the app is just how do you display that data and how do you interact with that, right? So if you take Spotify, for example, the data is like, what is your playlist? What are your songs? And the interaction is you get to see it, you get to add it, and then you get to play it. And the smallest form of this data is called a variable, which really just stores a single value, right? We can make variables as follows with variable name, colon, type, and then the value. And you can see two examples here. We have variable net ID of type string is equal to JN53. Variable current year is equal to, is of type int is equal to 2021. And then we can use these data by updating them, setting them to other things. So I can say like current year equals 2023. I can print that to the console. And then if I play up to this line, you should see 2023 gets printed out at the bottom right there. Cool. Oh, did you get the print off preview again? It should just appear on the right side as you're going. It might be that button in the top, right? It could be one of these buttons. I think it's live view question mark. I don't know. What about the one to the right? This one? No, this one splits the screen. It's definitely something in the layout view. You can look at it, and once you figure it out, let me know. Like this? Oh, okay, yeah. So if you can just drag it like this, that works. Thank you. Cool. So there's three things that we want you to note about variables. First of all, the difference between a constant and a variable. In this case, constants are constants. They can't change, right? If I'm setting someone's net ID, I don't want to be able to change that, right? That's their net ID. So that's a constant. And then similar thing with year, but if this is a variable year, it's a var. And then again, if we try to edit this, let's say like constant net ID, if I try to set it to my net ID, AVL96, and then I try to run it, Swift will get mad at me and be like, haha, we can't assign it because let is a constant. That's the first thing. The second thing about Swift variables is that they're strongly typed. For those of you coming from Python, Python is not a strongly typed language, right? We have strings and we have integers. If I say this variable is a string, it will forever be a string. I can't reset this to an integer no matter what. Like if I tried down here to say first name is equal to 10, and I tried to run it, it'll still get mad at me being like, we can't assign a value of int to string. So strongly typed is the second thing, but kind of confusingly, the third thing is that Swift is type inferred. So we have these type annotations everywhere, but they're actually not needed. So in this example down here, we have variable last name equals, and then a string. We still can't change this to anything but a string, right? It's still going to be strongly typed. If I say last name equals 10, it's still going to get mad at me. But what's happening behind the screens is that Swift is seeing this. It's seeing that we have our two quotes, that it's a string, and being like, we're going to make this variable a string forever. And you can see if you press Option on your keyboard and click on that variable, hopefully it'll be bigger on your computers, but it says variable last name is of type string. It automatically assigns that for you. Cool. So the three things that we have is that constant, strongly typed, and type inferred. Does anyone have any questions at this point? Cool. Next I'll go into printing. I've kind of touched upon this at the beginning, but again, I can print things out to the console. I can say print hello, and if I run it, it will be annoying, but if I run it and it works, it'll print out hello. And then what if you wanted to print out the value of these variables, right? I could just print out the value of this variable, right? I could say print out first name, and you'll see Justin pops up. But if I wanted to include that in a string and say something like my name is, the way to do that is wherever you want to put the variable, you have to put backslash, open paren, close paren, and then put your variable in these parens. So here I can say first name space last name. And then if I print it, it'll say, my name is Justin Nye. And for those of you who don't know Justin, he was the previous course instructor before me. And well, he co-instructed with Elvis last semester. Cool. Moving on, the next topic we have is arrays. So what are arrays and why are they useful? Arrays are basically just a collection of values. So you can see here, we have this first variable lecture numbers, which is a collection of integers, right? We have multiple integers that we want to store in a list-like structure. So we use an array where the first value is 1, second is 2, and so forth. Now to declare arrays, it's kind of interesting because of the whole like strongly typed and typed inferred thing that I was talking about. Whereas if I wanted to make an array that was just empty, it doesn't know what type of variable should go in this array. So if I wanted to do this empty thing, I have to explicitly type annotate it, as we've seen before, or I can do what's called the constructor and say this is equal to constructed an empty array of integers. And again, it's strongly typed. So if we try to access the first element using brace 0 and set it equal to not an integer, it'll get mad at me and say, cannot assign type string to subscript of type integer. But if we access the 0th element again and try to set it with 5, it'll work. Cool. So there's three main operations with arrays that I'm going to go through. The first of which is modifying the array, right? If these are just collections of values, I can index them and say, for example, the first element, which since we're doing CS always starts at 0. So the 0th element just in here, we're going to set that equal to Elvis instead. right? This is modifying what's already there, replacing Justin with Elvis. Again, I can say replace the second item with Alden. And then if I print out before and after and I run this code, you'll see that before we have Justin and Noah, and then after we've modified it, we now have Elvis and Alden. So what if we wanted to add a new one, right? What if we said course instructor 2 is equal to Walker White? And then we run it, we get an error that says fatal error index out of range down there, and then a whole bunch of random gibberish. This just basically means that at this point in time, our array has 2 elements in it. So when we try to access the third one, it says can't access it because it's out of range. Can't do that. So instead, to add a new element, what we do is we do what's called appending. This is very similar to Python, but I can say course instructors dot append, and you'll see Switch is very nice. It gives you autocompletes everywhere with what you need to add. So I can select append and say Walker White. Oh, we already have that there. And then if I print it out, we can see that as it runs, sometimes playgrounds get a little buggy and don't run the way we want them to, but that's okay. We'll deal with it. Cool. So after we've added it, you can see we have our new element Walker White in the third place. Cool. And then lastly, removing is very similar to append and structure. We just put course instructors dot remove and then the index we want to remove. So let's say we wanted to remove Elvis as a course instructor. Then we print before and after, you can see Elvis is now gone because we removed the 0th item. And then just as a demo, if we removed something from an empty array, it gives us a similar error as before, which is index out of range, right? There's nothing at the 0th position. You can't remove a non-existent item. Nice. Does anyone have any questions? Yes. Not that I know of. I think the way to do that is probably to initialize it and just add on 5 integers after it. Does anyone have any other questions? Okay. Well, the way to do that would probably be to initialize an empty array and then add it on using a loop, our next topic, conveniently. Yay. So with loops, we have this empty list and we want to add 10 integers, right? What we do is we can use this syntax for num in, and then this is what's called a range. For num in range 1 dot dot less than 10, which basically means we're gonna run through whatever's in these curly braces, and num here will be a new variable that takes on the value of all of the elements in that range. So the first time it'll be 1, second time it'll be 2, all the way through till 9, because we're doing less than 10. And then if we run this, you can see that, well, if we print out loop after, we can see that it has added all 9. So we have 1 to 9 at the bottom, right? We've just initialized it with an empty list. And then similarly, just an example, we can leave out the less than and it'll go 1 to 10 instead of 1 to 9. Cool. So now as an example, well, does anyone have any questions before I go into the example? Cool. We're gonna simulate rolling 3 die. And the way we're gonna do this, the logic is we're gonna have an array. We're gonna loop 3 times, generate 3 random numbers, and add those all to the array. So I can say variable rolled die equals, and I'm gonna make an empty integer array. Then I'm gonna use my loop to loop 3 times for I in 0 dot dot less than 3. So this will run 3 times. We just need to now generate a random number and add to the list. So I can say let die roll equal, and then the way to generate a random number is int dot random in, and then you can see we have this range element here, which is again just the same thing as a loop range. I can say 0 or 1 dot 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 6. Say generate a random number between 1 and 6. And then from here, I can just add it to our array, roll die dot append die roll. And at the very bottom, I can print out my roll die. And you can see we have 563, our 3 rolled dice. And since it's random, every time I run this, it should generate a new set of random numbers. Cool. So just a small note, we have this yellow flag here that says immutable value I was never used. We don't like yellow flags. If you have them, it's better to remove them, but they don't necessarily make your program crash. So in this case, it's saying we never really use I, so why don't we just delete it and replace it with non-existent value. This just kind of tells you and tells Swift that this variable I will never be used. And that way we can just loop 3 times and not have to worry about it. So a more common way to loop through things than doing the for I in and then arrange is to have it be for what's called a for each loop, where instead of looping through a range, we say for, and I'm going to put die here in, and I can put my roll die variable. And just like in our how I took the values of the range, this time die is now going to take the values within this array. And if I print out each die roll was, you'll see that once we run it, it'll generate our random array, and then it'll loop 3 times with die taking on the values and printing them out. So we get 1, 6, and then 1. Cool. So the next topic is dictionaries. In my brain, dictionaries and arrays are kind of similar. They work entirely different behind the scenes, but I like to think of them as similar because just as we were having these values assigned by indexing, dictionaries are having values assigned by keys. So I can have a pantry that has a string and an integer as a key, and I can say like apple will take value 2. So instead of just a list of integers and like a list of strings, you now have it as a pair. And a good example of this is here with variable emoji meanings. Our keys are these emojis, and our values are what they mean. We just put emojis because we thought it'd be fun to show you that you can use emojis in Swift. If you want, you can basically write your whole program in emojis. Don't do that, but you totally could if you wanted. And similarly, we have the 3 like methods of initialization that we had before, right? We can assign it a value from the start. We can make it empty and explicitly have a type, or we can initialize it with an empty type. And again, we have 3 operations, same as before, but this time add, you notice we don't need to append, right? Dictionaries are kind of nice. They let you just stick it in the dictionary. So I can say pantry apples is going to have a value of 2. I can modify it just doing the same thing and say 4 instead, or I can remove it. And then just as an example, I'm going to print out pantry here and print out pantry down there. So if I print out pantry, you'll see we have 1 item in the dictionary that's like value 4, and then I can remove it and it will be empty. Nice, so we have a dictionary and then empty. And just like looping through an array, we can loop through a dictionary. But again, since it's a key value pair, we can just have it be the key values. Instead of putting 1 variable here, it'll now create 2, emoji and meaning, for the keys and values. And so if we run this, you can see emoji takes on the value of, wait, I'm gonna just move this down here. So emoji takes on the value of the key, and then meaning takes on the value of meaning. And then as we print it, we can say this emoji is known as the blank emoji. And if I wanted to just do the keys or just do the values, that works too by just doing dot keys. So I can say emoji in emoji meaning dot keys, or emoji in or meaning in emoji meaning dot value. And again, if I print it out, you'll see we have this being the pair, we have this being just the emojis, and this being just the meanings. Does anyone have any questions at this point? Nice. So now we'll move on to functions. Functions are basically isolated segments of code that can be run. So in this example, I made a function called print something. And around these braces, you have whatever you want to do, any number of lines of code. And if I run it, you'll see nothing actually happens because this function never gets run. So to run it, I can just call the print something function. And then if I play this down to here, you'll see that it prints something. Now, the nice part about functions is that they can really help organize your code, right? If I have this bit of code, I can have it repeat as many times as I want. Like if this is 100 lines or something, it'll do all 100 lines just these 4 times, such and such. So it gets useful for organization. But the other usage of functions is for inputs and outputs. So in this example down here, we have a function that takes in an input and gives out an output. In this case, our input being 2 integers. So we have integer A, integer B, and then the output is an integer. And then to convert the input into the output, we do whatever we do in the function. And then at the very end, we have return on whatever we want that expression to be. In this case, A plus B. And then when we call it, we just stick in those inputs. A is equal to 2, B is equal to 3. And then we can use this. This add will evaluate out to the return statement, which in this case is 5, and gets set to this variable. And then you can see if we run it down here and print it out, it prints out 5. Yay. So the 3 main functions of the 3 main goals of functions are like inputs, outputs, and organizing code and keeping general structure. So now we have optionals. This is one thing that's slightly more unique to Swift, which is we can have variables that are optional, which means basically they can be null. They can be nothing. It's like taking a variable and putting a box around it and saying this variable might exist and it might not exist. We don't know. This gets really useful when you're dealing with pulling data from online, right? Like let's say we don't know if we have internet or not. We try to pull data. We don't know if that data is in the variable or not. So it has to be optional. It might exist and it might not. So this is a non-optional declaration, right? We just have our type string hello. And if we try to assign it to a nil value, nil meaning nothing, the empty box, it says cannot assign it to type string because it's not an optional. But if we make it an optional and we do that by adding this question mark at the back of the type, then we can assign it to nil. And then this will totally run and be happy. So let's say you wanted to use that value that you got that you don't know exists. You have to kind of check to see if the box is empty before you use it and assume that it's not, because otherwise it'll just crash your code. And that's what's called unwrapping them, right? You can think about unwrapping the box to see if there's something inside of it. So the unelegant way to do that is to just check if it's null, right? We have our optional string up here. We can say, is this optional string not equal to null? And then if it is, we run the code, right? So at this point in time, it isn't equal to null because we have this value, and it prints out this string is wrapped in the optional hello world. And then again, if we set this to nil, and then run it, this won't print out, right? But this is really bad, and you should never do this. In fact, actually, if we see statements like if something equals nil in projects, I think that's automatically -1 point because this is just a really bad practice that you should never do. Instead, the way to do it is what's called if lets. Well, actually, there's 3 other ways to do it, but most commonly is the if let, which instead of checking if it's equal to nil, we're going to allow Swift to do that check by itself and say, if it isn't equal to nil, set it to a variable, right? So we have our optional string, hello world. We can say, if we can let this new variable, unwrapped string, equal this value, and it's not nil, then we're going to run all this code inside the if statement. But if this is nil, then this code won't run, right? So we have 2 examples, one where it isn't nil, one where it is nil. And then once we run it, you'll see that we have this one value wrapped in optional string is hello world. That's from up here. I should probably run them separately. Right here, it's not equal to nil. So this variable gets set as a new variable that is the unwrapped version of this optional. And then we can use it, but only inside the if statement, as if the if statement executed. And vice versa, if it is nil, then this will just evaluate to false. It can't be assigned, and then we ditch this altogether. And it's like a failed if statement kind of thing. And then note with if lets, the variable is only accessible inside the if statement. Secondly is guard lets. I think of guard lets as kind of the opposite of if lets, because if lets checks if you can let a variable be equal to something, and then if it is, you assign that in the curly braces. Guards is the opposite, right? We have this function here. Where we pass in an optional string. We guard let something equal this optional string. And if it is not optional, if it has a value, then it'll skip this part of the code and continue on with this value assigned as this. If it is nil and it doesn't have a value, then it'll go into this else statement and say, this assignment can't happen because it's nil. So we're going to guard let return out of the function. And again, if we call this function, the input is our optional string. We can pass in a nil and we can pass in a value and see that when it's nil, the guard will not let us pass and will return out of the function. If it is not nil, it will continue on, skip this part, and use this variable that we've assigned up here in the code that the guard is written in. And lastly, the last way to deal with optionals is what's called a coalescing operator, which is basically just, if it's nil, replace it with a new value, right? So if we want to say a new variable, let unwrap string with default value equal optional string. If this is not nil, it'll use that value. If it is nil, it'll default using these double question marks and go to this value, right? So again, we have two examples. If it's not nil, it uses hello world. If it is nil, it uses, uh-oh, looks like that box is empty. And then if we run it, you can see the first part, use hello. Second part, uh-oh, the box is empty. Cool. And then lastly is force unwrapping, which is basically if you're 100% positive that your optional is not nil, if you know that there is a value in the box, you can just put an exclamation mark at the end and say, there's a value, right? So in this example, we have our optional string. Here, we know that this has a value, mainly because we can just see it right here, right? It has a value. So you can put our exclamation mark and say, we're 100% positive that's correct. Yes. So there are a few times where you actually use that. A lot of it's like, wait, I'm blanking on them. Do you know that?
Yeah, so optionals, a lot of the time when we're pulling the data from the apps, like say for example Spotify, that data is coming from the internet. And the internet might cut out, and so sometimes that data might not get to you. So use an optional because sometimes you don't know whether that data is going to be there or whether it's going to be there. And we want to make sure that our app isn't crashing this again. We want to make sure our app keeps running. Oh, no, I don't mean like optional generally. I mean like when you some app is just, you better be certain that it's not.
I think, yeah, there's a lot of times when you like know that you're gonna put a value in there, but you haven't yet.
For example, images. You might have an image like for your app that's for sure going to be like in the app folder. Like there's an app folder for the assets, so you have like this folder up. But like sometimes when you create an image, like Swift will like ask you like, are you sure that this is there? And if you are sure that there's something there, like the assets will be using it.
Yeah. It's kind of just like there will be a value, but I haven't set it yet. But again, this is risky and you only use it if you 100% know that there will be a value there. Because if you don't, this follow example, I am so confident the optional has a value, but it doesn't, and then I run it, your entire program crashes and your app fails, it freezes, and then crash and burn. So again, only use this if you are 100% positive that you know your value exists. So kind of just to review optionals, there's unwrapping optionals, which is you can check for that it's nil, which is very bad and you should never do this. You can use if lets, guard lets, coalescing, or force unwrapping, which is quite risky and you only do occasionally. Does anyone have any questions on optionals at this point? Yes. I think it's mainly just that like this is the standard.
There's
Correct
other
me if I'm
ways to
wrong.
like check the like guard lets, if lets. Those are just more conventional ways than doing that. kind of like how you can concatenate strings using plus, or you can do the backslash parentheses. Like, sure, you can do both, but it's convention to do the backslash parentheses. Convention is like
I don't think it's bad in terms of your program won't fail or anything. It's just like, don't do that because it's frowned upon kind of thing. Yes. Again, there's times when you like know that you will have a value in the future, but you don't currently have that value. So the example Elvis gave is when you're loading in images from like the hard drive on your phone, you know that that image exists because you uploaded it. But when you actually open the app, that's not connected yet to the app. So you can, when you're writing code and you say make a new image, you're basically saying there definitely will be this image there because I uploaded it, but Swift just doesn't know that yet. So that's the main use case of it.
It's a lot more like real examples than
Yeah. Yeah. So just kind of crash course on Swift. Any other questions? Cool. Lastly, I'll move on to our last topic, which is structures and classes. The way that I think of structures and classes is that they're basically like making our own variable type, right? So throughout this course, throughout this lecture so far, we have like var episode, and then we said of type string or something like that. With structures and classes, we're making our own type, right? This episode is now of type episode. And I can set it equal to a new episode using this constructor here, where see we have our variable name and duration in there. We can put name by adding in the name. So episode 1, super creative, duration, like 40 minutes. And then this is a new variable, right? With kind of sub variables in it, name and duration. And I can access these sub variables by using dots. So I can say episode, I'm going to rename this variable just because it's confusing. So EP is our variable name. I can say EP.name and I can print that out. So it's kind of a wrapper for other variables and also functions. And then again, I can like reassign things. So I can say EP.name equals new episode. And then again, I can print out the name down here. And you'll see it'll print to the console new episode instead. Similarly, we have classes, which are very similar. I'll get into the difference shortly, but within these structures and classes, you can have variables and you can also have functions. So if I have a class podcast, I can say, I'm going to create an instance of this class. So I'm going to say var a podcast equals podcast with name detour. And it's going to have a list of episodes in it. Detour is a podcast that my friend is actually working on at Cornell. So you should check it out if you have the time. But we have podcast detour and I can put in an episode here. Again, by making a new episode with name episode 1, duration like 30 minutes. And again, just like this has its variables, I can call its functions too. So with my a podcast, I can do a podcast dot play podcast, and it'll run this function, which belongs to this object. So if I play up to this point, you'll see it'll print out that this episode is sponsored by Detour. It isn't, but you should check it out anyways. Cool. Does anyone have any questions on structures and classes before I get into the difference? Okay. The main difference is the way that they're managed in memory. 90% of the time when you're building apps, you're probably going to be ending up using classes. But structures are used more for like storing data. Classes are used for main groupings of functionality. And a lot of the difference is, again, the way that they're referenced in memory. So a class is what's called a reference type, and a structure is what's called a value type, which means that when you pass them around, classes get passed as references and structs get passed as values. So I'm going to give an example. Let's say I make my podcast up here. I'm just moving that down. So I have my podcast, which I'm going to name pod, which is equal to the Detour podcast. If I make a new variable and I say new podcast and I assign that equal to pod, what's happening, because again, this podcast is a class, is we have this pod made in memory with a variable pointing to it. We make a new variable and it just passes a reference that points to that same place in memory. So if I do new pod dot name and I set it equal to something else, and then I print out my old podcast's name, what do you guys think will happen? Yeah, something else. Again, it's passed by reference, so now these two variables are pointing to the same place in memory. You edit one, you're editing the other. Again, with structures, if instead, I'm gonna just go up here and change this from a class to a struct. If I do this now, it's a structure. So instead of being pointing to the same memory, what it actually does is it takes this, it copies it over in a new place, and it says, now these two variables are going to be pointing to separate places. So if I run this, now what will happen? Yeah, it'll be the old name. So this will stay detour, even though I can print out our old podcast's name. And you'll see that they're now two different places in memory with two different values. Yes. Yes.
First one, so struct are allowed to have function.
Yes. Yeah.
So why you have to use instead of just using struct?
So there's a lot of advantages to both, and they're kind of used in different situations. A big thing with this is if I need to make any small change, if I need to reassign variables anywhere, I'll have to copy the entire thing as a struct. And if you have a really big class that represents maybe your like, I don't know, your entire app's user interface, and I need to copy that entire thing, that's just putting a lot of load on your app. So for that, you use classes.
My other question is, for class, by default, if I assign it to a new variable, it's copy the reference, right?
Yes.
Is there like a class copy constructor kind of usually? It's okay for them.
I think so. You?
So basically, it copies a class as it copies the reference. So it copies the object, but what?
I don't think there is. You mean like if there's an instance sign like a class or a variable, you make sure that that variable is
Like how do you print a deep copy of?
I don't know if there is, but 90% of the time you won't need it when building apps, if there is. Yeah, you want to just Google it? But yes. Does anybody else have any questions? Cool. I think that that's pretty much all we have for today. I think we can jump into the Kahoot for attendance. I just do have the Kahoot. Yeah.